we're going to talk about correlation versus causation. So first let's define both and talk about the difference between them. Correlation is a statistical way to measure the relationship between two sets of data. So data that has a relationship, it can be correlated, but it can also be described mathematically. Another way to think of it is how closely two sets of information of data data are related. While causation means that one thing actually causes the other. That causal relationship exists if one occurs because of the other. Proving causation is actually very difficult because there are no set rules or criteria for determining whether or not the relationship is strong enough to prove causation. But typically, the more robust or the stronger the correlation, the more likely they are to imply causation. For example, the link between smoking and cancer. For several years, there have been lots and lots of studies that were conducted talking about the correlation between cancer and smoking, and it is basically to the point where the correlation is strong enough that now it's really considered more of a causal relationship, not just correlated. And most medical people believe that smoking actually does cause cancer. So is it possible to have correlation without causation? So there's a correlation between the two, but not necessarily causation. Here's an example. There's a correlation, there's a relationship between the number of firemen fighting a fire and the size of the fire. So the more firefighters that are actually at the scene typically means that there must have been a bigger fire. So the more firemen there are, the bigger the fire was. However, that doesn't mean that if the fire department shows up with a lot of firemen, that's going to cause the fire to be large or to increase. So let's talk about correlation and causation as far as examples. So let's go through each of these and decide what they are. My suggestion to you would be to pause this video, read through each of these examples, and then once you've decided whether it's correlation or causation, play it back again and I'll talk through them. The first example is a recent study showed that college students were more likely to vote than their peers who were not in school. So is that correlation or causation? I would say that is simply correlation because although there is a relationship, being in college is not going to cause you to vote. Dr. Shaw noticed that there was more trash in the hallway after second period than first period. Again, that would be correlation. There's no causal relationship there. You hit your sister and she cries. Well, what you did, you hit her, caused her to cry, so that would be a causation or a causal relationship. How do we measure correlation? Correlation is measured by what we call the correlation coefficient, and we use the letter R to denote that. The correlation coefficient is always a number between -1 and +1, and we'll talk about what those specific values are in just a minute. And then there are 4 traits to correlation: the form, which is the shape, the direction, positive or negative, the strength, strong or weak, and then whether or not there are outliers. And in this lesson, we're not going to discuss how to determine what the correlation coefficient is, just to recognize mainly by visually what those 4 traits are. So let's look at form. We've got linear, so notice that the pattern here is linear. Quadratic, if you remember, a quadratic is a parabola, so we've got that basic parabola, which is my U-shaped. Looks like a parabola. And this one happens to be upside down. We also have a cubic, basic shape of a cubic. No correlation here. And then exponential, remember exponential, this would be exponential decay. So that's form, which is basically the shape. Direction, just like the slope of a line, we've got positive and negative. The strength. The weaker the correlation, the closer the value is to 0. So in this case, we've got a weaker correlation all the way to a stronger correlation, so it would go from 0 to 1. And then it would go the same in the opposite direction. So if these were negative correlations instead, 0 would be a weaker, and closer to -1 would be a stronger correlation. It's just a stronger negative correlation versus a stronger positive correlation. And then the last one is outliers, recognizing the data that does not fit, those outliers that don't fit the shape or the form. We're going to talk more about scatter plots in a future lesson, and how to identify the line of best fit, but right now we're just going to look at this one. We often use scatter plots to plot bivariate data, or in this case we've got study time versus test scores, and each variable is represented on an axis and they're labeled obviously accordingly. Just as a side note, if you have time as one of your variables, 99% of that time, 99% of the time, any unit of time, is going to be your x value, because that's your independent variable, and time is independent. So that's why 99% of the time your time is your x. If you read the graph below, it says, by reading the graph below, do you think that there is a relationship between the hours spent studying and exam grades? Well, if I look at that trend, it looks like a fairly strong positive linear correlation to me. So as your study time increases, your test score increases as well. All right, looking at positive versus negative. If y tends to increase as x increases, then it's going to be positive. But if y tends to decrease as x increases, it's going to be negative. And then an example of no correlation, there's really no shape to that. Correlation coefficient, denoted by r, is a number from -1 to 1, and we talked about those, so I'm not going to really talk about that much. I do want to see if you can come up with an example of negative correlation. Again, maybe pause the video, come up with your example, and then play it again. A pretty common example of this would be the relationship between the gas in your tank and the miles driven. Alright, so if I were to create a scatter plot, this is my miles and this is my gas. As my miles increase, my gas would decrease. So the further I go, the less gas I have in the tank of my car. So let's look at some of these practice problems. When I look at this, I want to not only see, okay, is there a correlation, positive or negative, but also what you think the correlation coefficient would be. Remember that the stronger, the closer it is to -1 or 1, and the weaker, the closer it is to 0. So for this first one, again, I would pause it, maybe decide that on your own, and then play it back for the answers. For this first one, I would say there is a relationship, a negative linear relationship. However, I wouldn't say it's very strong. So I would say that it is negative correlation. And I would say that the correlation coefficient is probably closer to negative 0.5 rather than -1. This one right here, to me, doesn't appear to have any correlation. Alright, decide, again, pause the video, read through these, and decide whether there's positive correlation between the two, negative correlation, or no correlation. So for A, it talks about the amount of exercise and the percent of body fat. So the more time that you spend exercising, we would assume that the percent of body fat would decrease. So if my time is here and my fat is here, as my time increases, my fat decreases. So this would be negative correlation. A person's age and the number of medical conditions they have. So we've got age here and medical conditions here. So as somebody gets older, typically they have more medical conditions, so this would be positive. Temperature and the number of ice cream cones sold. For this one, as the temperature increases, the number of ice cream cones sold would also increase, so I would say this would be positive as well. D, the number of students at CHS and the number of restaurants in Atlanta. Well, the number of students at Chestatee has no impact on the number of restaurants in Atlanta, so I would say that there's no correlation here. And finally, the age of a tadpole and the length of its tail. As the tadpoles get older, the length of their tail actually gets shorter because they become frogs. So that would be a negative correlation. Alright, putting them in order from weakest to strongest. Again, pause it, put them in order, and then play it back. So let's look at this example. Notice that the positives and negatives don't matter. It's really just the value of the decimal, because the larger the decimal, the closer to 1 the decimal is, the closer to 1 or negative 1, the stronger the correlation. So this would be for example 1 and for example 2. Matching the correlation coefficient to the graph. Again, for each of these I would pause it and decide on your own what you think, and then go ahead and make that choice. Alright, so for this graph we've got a positive correlation, which means these two are out. I would also say 0 is out because it seems to be, there seems to be some sort of correlation there. So basically we're deciding between these two. Is it strong or is it not as strong? Now to me, strong would be if I draw my line of best fit, they're all pretty darn close to it. And to me these are a little bit more spread out than I would like for it to be strong. So I would say 0.5, positive 0.5 would probably be your best choice. This one looks like it's going to have a negative correlation, so again we're getting rid of the positives, and it definitely has a correlation, or there is a correlation there, so we're going to get rid of 0. So we're looking at these two, and to me, if I draw my line of best fit, those are much closer than in the previous example, so to me it would be a stronger correlation. It would be closer to negative 1. Continuing, strong positive, so positive 1. No correlation, so in this case 0. There does appear to be correlation there, but it's weaker, and it's also negative, so I would go with negative 0.5. Going through, let's talk about positive, negative, or no correlation. Again, I would read through these, make your answer choices, and then play it back. The number of hours you work versus the amount of money in your bank account. Typically, the more you work, the more money is in your bank account, so there would be a positive correlation there. The number of hours that workers receive safety training versus the number of accidents on the job. Well, the more training you receive, the fewer accidents there should be, so that would be a negative correlation. And the number of students at CHS versus the number of dogs in Atlanta. there's definitely no correlation between the two. Again, read through these, make your choices, and then play it back. The number of heaters sold versus the months in order from February to July. So my months would, as my months go from February to July, it becomes hotter, which means the number of heaters sold would decrease, so that would be a negative correlation. The number of rice dishes eaten versus the number of cars on I-75 throughout the day. Definitely not any correlation there. And the number of calories burned versus the amount of hours walked. Well, the longer you walk, the more calories you're going to burn, so that would be a positive correlation. Let's talk a little bit more about correlation versus causation. Even though there is a strong relationship between two variables, that does not necessarily mean there's a cause and effect relationship. They may both be related to some third variable that is actually what causes it, and it could just be chance or fluke or whatever it might be. So let's look at a couple of examples. During the month of June, the number of new babies born at the Utah Valley Hospital was recorded for a week. Over the same time period, the number of cakes sold at Carlo's Bakery in Hoboken, New Jersey was also recorded. What can be said about the correlation? Is there causation? Why or why not? Alright, so we've got our number of babies born down here, number of cakes sold over here. Now remember, this is in Utah and in Hoboken, New Jersey. And if you look at it and were to draw a line of best fit, there seems to be a positive correlation there. But I would assume that is just really because of chance. Has nothing to do with anything. Now, if we were talking about number of babies born at Utah Valley Hospital versus the number of balloons sold in the hospital gift shop, that would be different. But in this case, these have nothing, there's no relationship between these two, and therefore I would say that there is no causation because they're not related at all. Mr. Jones gave a math test to all of the students at his school. He made the startling discovery that taller students did better than the short ones. His statement was this: as your height increases, so does your math ability. What can be said about the correlation? Is there causation? Why or why not? So he noticed that as the height increases, so your math ability increases. So he noticed that there was a positive relationship or positive correlation between the two. However, I would definitely say one does not cause the other. In fact, those of you that know me, I am quite short, and I would like to say that I have pretty strong math abilities. So I would say one does not cause the other. Why or why not? There's no relationship between height and mental ability. The last example says, in this present economy, families are trying to find ways to save money. Families might be thinking about not eating out in order to spend less money. The causation statement is this: the more you eat out, the more money you spend at restaurants. What can be said about the correlation? Is there causation? Okay, so in this case, the number of times you eat out versus the money spent at restaurants will increase. And what can be said about the correlation? There's definitely a positive correlation. Is there causation there? I would say yes, because if you eat out, that's going to cause you to spend more money at restaurants. So I would say that one does cause the other. Hopefully, some of these examples about correlation and causation are helpful, and hopefully you learned the difference between the two and how to identify each of those.